i-share to everyone my course guide para alam niyo kung ano yung mga topics and also the course requirements and the distribution of percentages that will comprise your final grade. Okay? So let me share my screen. Klaro na ba? Kita na ba? So our topic, so this AMAT 191 actually is a sort of a catch-all course. What it means is that depends on who is teaching the course, he will be teaching the subject kung ano yung pinaka-comfortable siya i-teach. And also, not only that, but also ano ba yung mga topics that are popular or relevant that was not considered at the time the AMAT curriculum was being revised. So I chose machine learning because it's really a hot topic nowadays. And one of the possible opportunities for AMAT is to work in companies that involves modeling as well as involves statistics, data analytics, and also machine learning. Mas maganda na ma-introduce kayo dito sa machine learning so that you can also use this in your thesis if you plan to do a thesis that will make use of machine learning. Okay, so in short description, so course goal natin is to cultivate a deep understanding of the principles of machine learning by acquiring theoretical understanding of machine learning concepts, working with the equations underlying machine learning, and of course to implement some machine learning techniques. So when I say implement, it means that sometimes we are going to work it from the basic principles all the way up to the algorithmic considerations. Okay, and after completing this course, you should be able to describe different machine learning technique concepts. You should be able to implement machine learning algorithms. You should be able to compare and contrast different machine learning algorithms to train and evaluate machine learning models and demonstrate competencies in using machine learning tools to solve a real-life problem. Not just like statistics, there are many techniques that have been developed for machine learning. So in practice, you're faced with a choice which machine learning technique you're going to use. So in this course, I will also teach you how to make those choices. Okay, whether it's more appropriate to use one technique over the other. Okay. So ito yung mga topics natin. Some of these are a bit, dense siya. So there might be some changes in the topic depending on the your progress. Okay, so I might be depending on your progress on early topics, I might adjust succeeding topics. Okay. So we will be asynchronous and also synchronous, just like what we're doing now. And these are the course material and a book. We will use Bishop, pattern recognition, and machine learning. Okay. I will also upload a e-copy of this book, and you can also use other introduction to machine learning. So basically, we are now in the third week. Okay. So itong mga topics na yan, hindi naman yan siya masyado. It's just review of different fundamentals of machine, fundamental concepts that will help you understand higher level concepts in machine learning. And one of those is actually probability. So very nice yung ating courses ngayon kasi meron tayo probability that we can also use in machine learning. Okay. So we'll be discussing linear models for regression on third to fourth week. Then linear models for classification, neural nets and deep learning, which is a very interesting field. And then we are also going to study kernel methods and sparse kernel machines, mixture models in EM and inference, and of course sequential data. For the course requirements, we have 2 long exams, 10% each final grade, a final exam, which is 15%, exercises, which is 15%. So most of the exercises are from our textbook. I'm going to give you some exercises from the textbook that you're going to provide solutions. Okay, and also practical exercises and projects. So this practical is actually sort of lab. Wala ang lab ang course natin, but ito yung kumbaga hands-on natin wherein we're going to develop some or do program some machine learning or implement some machine learning algorithms. And then there's also the project, which is 30% of your final grade. It's very important. Okay, 30%. So it's almost like 1/3 of your grade. So very important that the project is project. We'll discuss the course requirement. We'll have one long exams and final exam. Okay, so usually nandyan naman yun kung kailan siya naka-schedule. And same with the final exam, which is usually at the end ng semester. And then meron tayong exercises. No? Students will solve 2 to 3 exercises from Bishop's book. Of course, I want you to really work on that before looking at the possible solutions, okay? Because that will help you better understand the topics. And for practical sessions, meron tayong mga practicals dyan. Ito yung mga topics natin for each of the practical. And we have also some objectives for the practical sessions. For project, so this is very important because at the end of the course, students will submit a project that will solve or that solves a real-life machine learning problem. Okay, so additional information is provided below. So the project will be done by group. Okay, maybe kasi kaunti lang kayo, so dalawa lang siguro per group. Ito dalawa lang to siya. 2 members should be 2 members each group. The instructor will form the group. So ako bala mag-assign kung saan kayo malagay. And then, of course, to yung mga schedule. Then how to pass this course, you just need to pass the practical and project and the long exam and exercises. So means that you need to get at least 50% to pass the course. Okay? For exam exercises and practical. So if you fail one of these, like you get a fail less than 50% for practical, then you fail the course. Same way, if you get less than 50% sa exams exercise, then you fail the course. Doesn't matter if you pass one of them. Okay? And then I will be your facilitator for this course and your instructor. Okay, so let's maybe have a lecture on, so I will share my slide. So we will have a discussion on, so of course I will discuss, I already discussed the course info, so I will just skip that. And then we'll have a short discussion on machine learning and some motivating examples, regression model selection, and of course decision theory, ML, machine learning, loss function, no, not machine learning, maximum likelihood, then yung ML, loss function, and maximum as priori. Okay, and probability theory is of course probability and parameter estimation. Course info, people, references, resources. Okay, so I will be your instructor. Textbook natin, pattern recognition, machine learning. Then these are all other useful resources that you might read. Then merong magandang course actually na machine learning by Andrew Nang. You can also watch this machine learning course. Okay. Okay, good. Assignment late, 5 grace period for assignments together. After the grace period, it's a % penalty for each. Then we will use either R or Python. Okay, so we'll cover techniques, standard ML toolkit. Marami-rami yan siya. And after this, I hope na you will be a better applied mathematician. Calculus, ano yung mga background knowledge na dapat para mas madali niyo maintindihan? Dapat calculus, alam niyo yung calculus. Okay, marunong kayo mag-compute ang derivative, partial derivatives. Okay. Integration, marunong kayo mag-integrate. Okay, let's have Dathlin. Dathlin.
Yes po, sir.
What's the derivative of 1 over x?
Negative 1 over x raised to 2. Or x
Okay.
squared.
Okay,
Negative
good.
1 x squared.
Ang unsay integral sa antiderivative sa x, e to the x. Unsay antiderivative ani?
E raised to the x quantity x minus 1 plus c po, sir.
Ana?
Plus c.
So, diba, sa'yo naman pag-check. So, first times 1, plus, diba, na?
Opo.
Ex, then it's my derivative 1. And then x minus 1 times ex. So, ex plus x, ex minus ex. Ma? So, therefore, cancel. So, tama. Pero unsa man mo gigamit nga technique?
Integration by parts.
Good. It's very important niya. So, just to check, you need to review this kung medyo hindi pa kayo masyadong gama sa integration by parts. Why? Because you will deal with a lot of e to the x. Remember that the normal distribution is actually involves e to the x, right? So, can equation 2 pi square root of 2 pi. Yeah? Always remember that because and of course yung exponential din natin distribution also have e x. Ang ganyan yata yung ano. Okay? So very important yan na maano talaga ninyo yung ating normal integration by parts na technique. Ay, divided by. Okay, so I think wala naman mo na. So good. And then also we have algebra. Right? Pag manipulate ng vectors, especially getting derivative of vectors. So this actually acts like a variable, diba? Xa, kaya lang this can be a vector. Okay? And a can also be a vector as well, or a constant or a scalar. Okay? And of course, probability, pinaka gamit is yung marginalization. So, yan dyan. Also the course marginalization for continuous kasi integral, and of course the expectation function. It's possible to refresh, but if you've never seen calculus and probability before, this course will be super challenging. But since meron na kayong calculus, meron na kayong algebra, meron na rin kayong kaunting knowledge or probability, then it would be easier for you. Okay? Okay, machine learning. So yan lang yung ating outcomes. So what is machine learning? So yeah, yung question, of course. So it's two words, machine learning. So when you say machine, what do we mean? Usually it's a computer or even a robot. Ano? But computer, of course, robot din is merong computer din yan, no? Electrical, electronics component. But usually our goal is just computer robot. In learning is the usual learning. How do we learn? Oh. So humans learn. How do we learn? I'm teaching you now. You're listening to me. And then maybe if you study, then you learn something. And the goal of machine learning is actually make computers learn. Parang bigyan natin sila ng capability to learn. But what do we mean by learning itself? It should be very precise. Why? Because it's a mathematical concept. We should be very precise in our definition of what we mean that something is learned. So maybe you can have these algorithms that automatically improve performance through experience. So just like humans, we learn from our experience. No? So the more experiences we have, the better we are at something, right? And that is actually the role of the algorithms. Okay? So if we can devise algorithms that somehow inject, that we can put in the machine, and these algorithms can improve through experience, then we say that there is learning. Often, this means defined by a model by hand and use data to fit its parameters. Yung ginagawa natin sa stat before, that we are estimating parameters. For example, linear regression. Usually, we have to compute for, estimate for these parameters. In machine learning, meron tayong term na ginagamit. Kung sa stat, we say we estimate. Sa machine learning, we say we learn. So instead of saying estimate this parameter, we would say learn these parameters. Yeah. And how does it learn? Of course, using data. Yun yung data kasi. Okay? So then sabi nga, data to fits parameter. It's just saying that use data to learn these parameters. And usually we say the more data, the more possible learning is. Okay. So I hope you get what I mean. So in a nutshell, it's just very simple. Algorithms that improve. It means that if you apply a certain algorithm to learn this parameter, the more data, the better are the estimates. Okay, yan yung ibig sabihin na machine learning. Okay, why ML? Why? Because the real world is complex, difficult to handcraft solutions. So what do we mean? Kung meron tayong solution, usually very specific siya to a problem. Okay, and that problem may not, that solution may not be applicable to other problems. Okay, and if you're going to create model for each changes, small changes lang sa ating minomodel, then maraming model ang ma-create. What we want to do is that isang model lang, and that this model can adapt to various situations kahit na mayroong kaunting changes sa mga sa components ng problem na yun. Kaya siya, kailangan natin ML. And ML is a preferred framework for applications in many fields in computer vision, NLP, robotics. Because computer vision is really very difficult. No? It's difficult to teach a computer how to see like humans. So ano ba yung mga applications ng computer vision? Yung object detection, yung image segmentation, yung object recognition, yung classification. All those problems in computer vision is very difficult to solve using traditional techniques. Okay? Kaya gumagamit tayo ng ML. Natural language. Okay? The language, yung language na ginagamit natin. So how do we make computers understand language? And how do we, kung napansin niyo dito sa YouTube, meron yung auto-generated na captions. Yung caption na yun, medyo pangit pa for Filipino, pero sa English medyo maganda na. And that's actually using ML. Because as we speak, it's generating the words as we speak. So yun yung isa sa application ng ML. Robotics as well. No? So yun ang mga application. So it goes to say that hindi lahat ng problem actually kailangan ng ML. Tama? Meron tayong mga problem that ML is more suited compared to other methods. Okay? Example is handwritten digit recognition. So, saan ba ito siya na-apply? Usually, nung uso pa yung pag-send ng letters, usually naglalagay tayo dyan ng zip code. Tama? Nalagyan natin zip code. Sa dami-dami ng letter, medyo mahirap na kung i-manually sort natin yung letters kung saan destination siya based on the zip code. So, ang ginagawa, nag-develop sila ng isang technology that can automatically read the zip code and assign it to the destination. Kailangan problema, iba-iba yung handwriting ng mga tao. For example, ito, ano tong number na yan? It can be 7, it can be 9. Ito, kung tayo ang titingin, parang 4, pero it could also be 9. Ito naman, 8, pero walang ganyan, it could be 3. No? Kahit tao titingin, minsan nahirapan. Tama? So that's why, how do you take into account all the different changes in the model or in the way we write numbers? No, kaya yan sinasabi niya, difficult to handcuff rules about digits. How do we know that this one is not 8 but 3? How do we know that this one is 2 and not 0? Kasi ito 2, ito din ay 2. Ito din ay 2. Ha? Halos magkaiba talaga. If you try to create a model that can recognize the image, the numbers, then it's maybe difficult for us to develop that algorithm or develop that technique. Okay. So for example, in this case, mukha 4 siya para mukha ding 6. So how do we represent? So I represent this as an input image. So naka-image siya. And suppose we have so usually it's R784 kasi this 784 actually is based on the resolution of the image. So ang resolution ng image na yan, kung 784, kukunin nyo lang yung square root niya. Kung rectangle. Kung perfect rectangle. So ano yan siya? (28 by 28). image pixels. Meaning 28 by 28. So, kung ano nyo yan siya, yan, di ba yan yung pixels? Kung yan lahat, i-connect nyo siya end to end, you will get a 784 vector. Okay, kaya yan yun yung input image vector natin. Then suppose we have a target vector is from 0 to 9. Then we can represent that as 10 vector of length 10. 0 siya sa ibang component except doon kung anong klase siyang number. So for example, this one corresponds to 1, 2, 2, 0, 1, 2. Gagawin na lang natin 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So notice that 0 siya for all the rest except for 4. It's because ang ating digit dito ay 4. So that's how we represent. Now, kung 1 naman yan, dito lang yung 1 and the rest will be 0. Okay? So na-represent natin siya into a vector input of length 784 and a target vector of length 10 wherein 1 yung number, 1 yung element doon sa position kung ano yung number natin dito. Okay? So given a training, so yan lahat, ito lahat yan is a training data. We can now construct a function, no, that maps this to this. And once we have that, we can actually apply to predict what would be the TI given a specific xi. Okay? Another is face detection sa photos. So siguro meron kayong cellphone, no? Or gumamit kayo ng cellphone, siguro Samsung or Android. Pag ipo-point niyo yung camera ninyo, mapansin niyo na nagde-detect siya ng faces. Kahit yung walang face, dinidetect niya kaya minsan nakakatakot. Kasi ano yung na-detect niya na face. Tama? So the same way here, yung ibang ang cellphone, it's not only face, but it's also smiling faces. Di ba? No? Meron na kasi mango. Facebook is also using this technology because yung tagging nila, sino ba may Facebook dito? Minsan, nagde-detect siya kung sino yung nandoon. No, nakakatakot kasi Facebook already has our mukha natin. So alam na nila kung ano, how we look like. Kahit nakatagilid, nakaharap, nakatuwad, or naka-side view, alam nila. So iyan ay isang application ng machine learning. They actually use machine learning to do face detection. Right? And this can also be a classification problem as well. And then our output is just non-face, frontal, face, or profile. So ito siya ay naka-profile, ito ay frontal, ito is naka-profile, at ito ay hindi face, kaya hindi siya nalagay dyan kasi kamay siya. Ito din ay hindi face, pero niya na-detect. Okay? That's another machine learning. And how about sa email? Meron kayong email, nakakatanggap kayo ng maraming, siguro mga email, tanggap na spam email. Minsan yung princess daw ng Nigeria or hari ng Nigeria, or may namatay somewhere sa Africa, tapos wala daw mapagmanahan. Those are spam emails. And as you notice, merong mga emails that are automatically put in the spam folder. And paano yan siya nagagawa? It's actually using machine learning. No example dito is yung Viagra. Well, ito naman is kung parati kayo nanonood ng porn, minsan napapadalahan kayo ng mga ganyang email, pero pasok pa rin siya sa spam. Same here, yung mga marketing spams. Okay? So yan is napakaraming application ng machine learning. Iba-iba, from email, from recognition, to detection, to classification using text lang. No? So, but the main idea here is how do you represent these objects? From image, from text, how do you represent them into a vector as input? Kasi computer knows only how to manipulate, or mathematical operations knows only how to manipulate vectors. Hindi siya makapanipulate ng ganyan. Kailangan mo i-convert yan into vectors. And of course, the output, which is always dictated by the problem. So in this case, you have 0, 1, it means non-spam or spam. Yeah, here it's using the count of words. So kung merong Viagra, kung merong stock, or for, or multi-bagger, and that could be an indication na maaari spam yung aking natanggap na email. Yeah. And we have a, of course, caveat for this. Just an example, no? Siguro anecdote lang ito. Once upon a time, there were two neighboring farmers, Jed and Ned. Each owned a horse, and the horses both liked to jump the fence between the two farms. Clearly, the farmers needed some means to tell whose horse was whose. So Jed and Ned get together and agreed on a scheme for discriminating between horses. Jed would cut a small notch in one ear of his horse, not a big, painful notch, but just big enough to be seen. And you wouldn't know it, the day after Jed cut the notch, Ned's horse caught in the barbed wire fence and tore his ear in the exact same way. So something else has to be devised again. So Jed tied a big blue bow on the tail of the horses, but the next day Jed's horse jumped the fence, ran into the field where Ned's horse was grazing, and chewed the bow right off the horse's tail and ate the whole bow. So what happens? Finally, Jed suggested Ned concurred that they should pick a feature that was less apt to change, correct? And height seemed like a good feature to use, but were the heights different? Well, each farmer went and measured his horse, and you know what? The brown horse was a full inch taller than the white. So what is this story about? It's about constructing good features to describe or characterize the objects. If you have good features that can discriminate, then you may get a good method to identify one object from the other. But if you have defined a poor set of features, then that might not be helpful. So what's the technique here? Try to look at features which are not subject to change very frequently. So in this case, height will not change that much, over a long period of time. Lalo na kung medyo adult na yung horse. Pero yung maglagay ka ng buo, pwedeng matagal ang buo, pwedeng kainin, pwedeng masabit, yeah? Or kung lagyan mo siya ng isang notch dun sa ear, it could be yung isa magkaroon din, not through yung intentional na pag-notch, could be result of accident. So those features tend to change a lot. So they are not good for discriminating objects. Okay? So ML is really on defining good features and models. If you don't have a good feature, if you don't have good model, then you'll fail. Okay. Okay. We have discussed spam detection, face detection, digit recognition. And those are actually what we call classification problems because we tend to classify them into categories. Kanina, 0 to 9 or 1 to 0 to 9. Yung isa naman is faces, whether na-profile, walang face or naka-frontal. Yung isa naman, yung last is either it's spam or not spam. Okay? Ito naman is not doing classification, but it's trying to do to predict a real number. And this is actually what we call regression problems. An example niyan is of course yung stock price. Okay, you can consider many variables. And you have a variable that you're trying to predict, which is the stock price, and this is actually continuous. Okay. So that's the classification regression. But sometimes, may mga problem din naman na walang outcome or walang output variable. Maybe your interest is more on how to group similar things together. We are not trying to predict kung anong class or category sila belong, but let's just try to see if we can find natural groupings or clustering. That's what we call it. Oh. For example, in this case, ito na-group sila. Ito naman na-group together, nakahiga sila. Ito, they are being grouped together na nag-pitch ng ball. Ito naman is nagbabat. Yeah. Ito isa hindi nasali kasi nagko-call lang siya. Ito naman walang ginagawa. Nagposing-posing. Ito naman protesta. No? Nagpo-protesta sila. Hindi sila nakasali sa question. So basically that's the thing, no? So you just want to find similarities and whether these different objects or different images can be clustered together. So kung wala tayong output, kagaya nito, wala talaga tayong output. That's what we call unsupervised learning. Okay? And cluster is another group, is not another, but an example of what we call unsupervised learning. Kasi nga, wala tayong output na gustong i-predict. So we have this taxonomy, supervised learning, and the gender classification regression, unsupervised, yung density estimation, clustering, hidden Markov models. And there's also a third type, which is what we call reinforcement learning. Hopefully, we'll be able to touch all of this in our subject. Okay, consider this. So you have these points. No? So sa tingin ninyo, can we fit a curve to this? Ano kayang curve ang pinakamagandang curve that can fit all of these points? So we call this our training data. And the line or the curve that we use to fit this is what we call the model. The regression problem. Okay. It could be like this. It could be like this lang, straight. Yeah. So marami possible. Choice is, saan dyan ang pinakamaganda? Pwedeng ganyan. Yan ang pinakamaganda. So we know that this is a polynomial, yeah, of degree n. This is what we call our hypothesis space. So if we define a model, a certain type of model, that's what we call the hypothesis space. So the hypothesis space is all polynomial of degree n. And what is the specific polynomial of degree n? That is what we need to estimate or to learn from our data. Here. So how do we measure success? So this success means how do we measure fit? Na ibig sabihin niya. Usually we do sum of squared errors. So yan, we compute sum of squared. And the data or the curve that results to the lowest or the smallest sum of squares, we can tell that that's a good fit. Okay. For this, so if we have here a model that we estimate, we subtract it to all the points, square it, and then get divide by 2, then we have the sum of squares. Hypothesis space is, of course, we need to decide on what model, right? And then we have to, since this is just the hypothesis space, it means that it's actually a family of models that we can use, parameterized by these weights. Okay, so depending kung ano yung weight, ano yung value ng mga weights, then you have a specific model. Now we need to decide how do we choose between several models. Kasi basically we have infinite number of functions or polynomials which we can use to fit here. So that's why it's important to measure success, which is the fit. Okay, among functions of the class, choose that which minimizes the error. Okay, hence we want to minimize the error. No, because higher the error, it means that higher the sum of squared errors, the poor fit we have. So these are the error function. This is the best coefficient. So the best coefficient is the coefficient that will give us the low or the smallest sum of squared errors. And we can find actually this using a pseudo inverse. Okay. So as you can see here, there's actually a lot of models that we can fit. So it's either a horizontal line, which has a negative slope, or this particular function. Or we can also create a function that really pass through all the points. Meron na ba kayong numerical analysis? Yung interpolation, yeah. Make function na nagpass siya lahat. So meaning this function now has a 0 error. Kasi walang error. Kaya the problem here is that ito yung tinatawag nating overfitting. No? It means that it fits well with the data that we have. We used for training or we used for estimating, but it may not generalize well when there are new observations. So ito siya is nag-overfit to. So kung kayo ang papiliin, saan dyan ang medyo okay na polynomial? Diba ito? Kasi ito yung green, ito yung true. No? Tsaka ito yung na-fit niya na polynomial. So we can say that this one is the better. Ito naman yung tawag nating underfit. In these two is somewhere in between, pero if we have to make the choice, then this one is the better. Okay? Hindi siya underfit, hindi din siya na overfit. Ang error din niya ay minimize. Okay? So yan yung isa sa problem talaga ng machine learning is how do we construct a model and how do we decide whether the model is a good fit or not. And that is the model selection problem. Okay? So ito yung sasabi ko kanina, that is overfitting. Ang error nga ay 0 kasi nga nag-pass siya sa lahat ng points pero nag-overfit naman siya sa data. So hindi siya nalampas siya sa ating true model. So bakit yung true model di naman lahat ng points ano talaga, nagpasa kanya, it's because of errors. Meron talaga tayo tinatawag na measurement error, observation errors. So we don't want to fit those because if we try to fit all those, na-fit din natin yung mga error, which is not good. Okay? So meron siya underlying function, but because of maybe various sources of error like observation instrument error, measuring error, or observation error, that's why hindi perfect yung ating data sa true model. Okay? Okay, so now we go to the concept of generalization. So what is generalization? Generalization means is the holy grail of ML. Means that this is what because learning is about generalization. So when you say, if I show you a picture of trees, when you are young, pinakita ko kayo ng mga picture ng mga puno. Now, I present you a new tree. Can you identify whether that's a tree or not? And that is actually generalization. It means that marami ako ipakita sa mga pusa. Meron akong bago ipakita sa iyo na animal. Can you identify whether it's cat or not? And that is a generalization. Kung sabihin naman natin na, ang cat natin dapat may tail, may ears, mayroon siyang yung ngipin na matatalas. Then that particular description might also fit other animals like dogs. Yeah? So yan yung tinatawag natin overfit. Lahat na lang gawin natin cat. No. And that is the holy grail of ML. Because we want good performance not on the data that we use to train our model, but also on new data generated by the model. And usually we measure generalization using a separate set, and we use root mean squared error. And this is the root mean squared. So as you can see here, meron tayong training, no? And this is actually error actually. Ito yung training, ito yung test, performance, test. Pagdating natin sa 9, nag-0 na ang error, pero sa test naman ay lumaki ang error. Yan yung nasabi natin kanina, nag-overfit siya. Okay? So this is not good. So maybe our model is somewhere here. Yung difference ng test training hindi masyadong malaki. Okay? Controlling overfitting, regularization. As order polynomial m increases, so do coefficient of magnitudes. Okay? And what we do, usually, one steps that we can do to control overfitting is through the use of regularization. So what I mean by regularization is that, notice here that as we increase the degree of polynomial, what happens? Lumaki din ang mga coefficients. You see? Lumaki siya numerically. Kung alisin natin yung negative, lumalaki siya. And this is actually an indication na nag-overfit siya kung masyadong malalaki na yung mga coefficients. So, what regulation tries to do is to come up a penalty function that will penalize large coefficients. So, ibig sabihin, maglalagay tayo ng penalty kung masyadong malaki yung coefficients. And this is the purpose of this quantity here. Kung ang ating masyadong malaki, ang ating coefficient, square pa natin, multiplyan natin siya ng lambda, lalaki din yung ating error. So, since our goal is to minimize this, we want our W to also be small. Correct? Kasi ang tendency kasi kung wala ito, ito ay magzi-zero. Then we have a good fit, pero nag-overfit pala siya. So as we decrease this, we actually increase this. So naglalaban siya. No? So kahit na ito ay 0, pero ito naman malalaki, hindi pa rin siya. Hindi pa rin maliit yung error. Ha? Kaya dapat ito siya, itong buong equation na ito, or itong buong expression na ito should be minimized. So siguro, kahit hindi ito 0, pero hindi naman ito masyadong malaki. Okay, that's the technique of regularization. Penalizing large coefficients. Yeah, so yan yung ating nangyayari. As you can see, overfitting. Regularization. So as we increase the lambda, so the lambda controls the contribution of the squares of the coefficient to the error. No? Kung masyado naman natin itong palakihin, malaki din naman masyado yung kanyang contribution. Kung masyado naman paliitin, maliit din naman yung contribution. So it's still a trade-off. Okay? Okay? So that's the regularization. Okay, lampas na tayo sa time.